Hello mathematics lovers, still on mean and standard deviation. We want to work another example, this time on confidence interval. Have you heard about that term before? In my last video, we worked the A part of this example about a class of physics students with 200 students. We were able to work the mean and the standard deviation, and we got these results. The mean was 61, the standard deviation was 15. So we want to extend these concepts. Look at it. It says physics class at a certain university has 200 students. The scores of 6 students selected at random has a mean of 61 and a value, a sample standard deviation of 15. Calculate the error margin, EBM, and construct a 90% confidence interval for the mean score of all the students. You are given a question like this. The first thing you want to do is you calculate the standard error, and it's given by this formula. Standard error equals the standard deviation all over square root of the number in the that you analyzed. So what is the standard deviation we're given? It is 15 all over square root of the sample size was 6, n equals 6. So if you work that out with your calculator, you will get a value of 6.12. Let's take it to 2 decimal places. Now the next thing is to work the error margin. This is the standard error, while this EBM is called error margin. And to work this, we simply multiply the standard error by this term, the t-test. The t-test at v, alpha over 2. This is they call it the two-tail value. Two-tail value. We are going to draw a sketch to show what the two-tail value is. And we're told that the v is equals the degree of freedom. And v is calculated as the sample size minus 1. So that's 6 minus 1. So our v is equals 5. I hope we got that. For alpha over 2 that we're seeing here, the alpha over 2 value, the one-tail alpha value is given by alpha over 2 is equals 1 minus the confidence level all over 2. So that means 1 minus, we're given a confidence level of 90%, so that's 0.9 all over 2. And 1 minus 0.9 is 0.1, so all over 2. So our alpha over 2 equals 0.05. Now these are significant. These are alpha over 2 value, and this our v value, and this we want to find the EBM. So at this junction, we are going to consult our t-test table. Here is the degree of freedom, which is the same thing as the v that we solved earlier. So v is equals the degree of freedom, and what result did we get when we solved it? The degree of freedom was 5, and then our alpha value was 0.05. Was that the result that we got? Yes. Our one-tail alpha value was 0.05. So we come to our t table. I hope you can see this. It's quite small, but please. So this is the degree of freedom. We have 5 here, and then we have 0.05. So we just trace it, and then we discover that our t value, t at alpha over 2 is equals 2.0150. 2.0150. We'll bring our formula here again. V alpha over 2 times the standard deviation all over n. So our TV at alpha over 2 is 2.0150 times our standard error was 6.12. So if you check your calculator, that will give you 12.3318. So let's take it approximately. EBM is equals to 12.33 to 2 decimal places. So what information is this value conveying to us? So this is the normal distribution curve, and the values that we got, our alpha was 0.05, and when you divide this by 2, so this region is the alpha over 2, this region is alpha over 2, and each of them will be like 0.025. So that's the information that is conveying to us. And in between here is our population, is our sample mean, which is the x bar. So we are trying to find out at what confidence level this data that we got deviate from this sample mean. The B part of the question says we should construct a 90% confidence interval for the mean score of all the students. So to do that, to construct a 90% confidence interval, because the sample mean plus or minus the EBM. That's all. So that gives us the sample mean was what again? Sample mean was 61. Plus or minus our EBM 12.33. So let me put it here. So the upper limit of the sample mean will be 61 plus 12.33. Sorry, I wasn't recording. So the upper limit is 61 plus 12.33, which gives us 73.3. The lower limit will be 61 minus 12.33. So that gives us 48.67. These figures are very, very important. This means that at a 90% confidence level, here you have 73.33, and here you have 48.67. So a little to the right, something to the right of the sample mean is 73.33 for a 90% confidence level is the highest you can go. While to the left of the sample mean 48.67 is the highest that you can go for a 90% confidence level. Every other data outside this point should be discarded. They do not really contribute much to the mean at a 90% confidence level. I hope I was able to explain this to statistics students very well. We may work one or two more examples to make this concept clearer. Thank you guys. Please share this video. Please comment. Please follow my page. Bye for now.